This is the summary created from the video. Lecture 41 Demonstration XV. This demo class covers AWT programming concepts from the last two modules, specifically including GUI elements like buttons, checkboxes, labels, and containers like frames and panels to organize components. It will also explain how layout managers in AWT can be used to manage UI layouts and illustrate how these concepts can be applied to develop applications. The demonstration begins with creating a frame and customizing its size and background color. It then creates a panel inside the frame, specifying its location and color. Next, a button component is explored with its label, text, bounds, frame size, and visibility set. The programs are executed to visualize the GUI elements and customizations made, with a detailed explanation provided for each code snippet and its output. Checkboxes in CFUF and Java are added, with a Boolean state representing their ticked or unticked status. The Java checkbox is ticked by default. The button size is then customized using the setBounds method, changing it to 50x60 for the demo. For layouts, the button dimensions are controlled by the HGAP and VGAP parameters. The checkboxless constructor is used to create checkboxes titled CFI and Java, and they are added to the frame with the Java checkbox initially ticked as the second parameter is set to true. An example without event handling is demonstrated, introducing the concept of a checkbox group, which is a group of checkboxes. A checkbox group with 3 items is created, 2 of which are named checkbox 1, checkbox 2. Checkbox 1, checkbox 2 are added to the checkbox group, and the checkbox group is added to the frame. The differences between a checkbox group and a single checkbox in terms of appearance are explained. A text field is created in this example to demonstrate its usage. 2 labels L1 and L2 are created and labeled first label and second label. The labels are positioned and added to a frame container, which displays both labels. It is explained that a container can include many components, with each example showcasing different ones. The text field component allows user input and generates events that can be handled by an event handler. The program creates 2 text fields, T1 and 2, with initial text and sets their position and size using setBounds. These text fields are added to a frame, which is configured and displayed. Users can position the mouse pointer inside the text fields and type text. The text area component, similar to text field, is also mentioned for user input. The main difference between a text field and a text area is that the latter can accommodate larger amounts of text. A text area provides sufficient space to accommodate large text like paragraphs. The example creates a frame, adds a text area with default text, and sets its size using setBounds. The text area includes both horizontal and vertical scroll bars to scroll through large text content, making it useful for applications requiring input or display of large text volumes. This portion explains how to create and add items to a list in a Java program, and how to use the setBounds method to specify the list's size. It notes that only up to 5 items added will be considered, and the rest will be discarded in the given example. It then shows how to add the list to a frame and demonstrates the item selection functionality in the list. The choice component is introduced, which is similar to a list but displays items in a drop-down menu style. The choice component is contrasted with the list, highlighting its more compact display and drop-down behavior for selecting items. The next example focuses on the scrollbar component, which can be created and included in a frame using the scrollbar class. First, a frame is created and then a scrollbar object is instantiated, specifying its orientation as either HORIZ, ONTAL or VERTICAL. The scrollbar's starting location, visibility, and range values are set, though event handling manages the actual values. Both a HORIZ, ONTAL and a VERTICAL scrollbar are created, added to the frame, and positioned accordingly. In the output, the 2 scrollbars can be seen and interacted with using the mouse. This section describes customizing the scrollbar size and tracking the mouse release location in GUI programs. It then explains creating a GUI applet with text field and button components to perform arithmetic operations. The applet layout includes labeled text fields and buttons for adding, subtracting, and other operations. User input is handled in the text fields. The specified operation is performed, and the result is displayed in a separate text field. The next example, which covers creating a similar GUI using frames instead of applets, is mentioned. The frame in this example is larger than the previous one and includes 3 text fields and 2 buttons. The program creates a frame container window, not an applet. The frame contains 3 text fields, 2 buttons, which are resized and handle events. By entering data in the text fields and clicking the Done button, a record is completed. The demonstration illustrates designing and handling a frame. The Flow Layout Manager arranges components from left to right in sequence. In the program, buttons 1-10 were added to a frame in program order, aligned by the Flow Layout Manager. The setLayout New Flow Layout method explicitly sets the Flow Layout Manager, which is left aligned by default. Changing the flow layout alignment to IGD alignment resizes the components, causing them to flow from right to left. Flow layout dynamically resizes components to fit the available frame area. The border layout divides the canvas into 5 regions: center, left, right, north, and south. In this example, 5 buttons labeled NORTH, SOUT each, EIST, WEST, and CENTER were added to their respective regions. Using border layout, components are placed in specified locations without setting explicit sizes. The default button sizes can be controlled using set bounds or by setting the gap and VGAP in the border layout. The Grid Layout Manager, which will be discussed next, is also mentioned briefly. The Grid Layout Manager can place many components in a grid format, with the number of rows and columns specified. In this example, a 3x grid layout is created with 9 grids to place 9 buttons. The buttons are arranged in the order they were added to the Grid Layout Manager. The grid layout displays the buttons in a larger size in this example. The next example to be covered is the Card Layout Manager. The Card Layout Manager allows displaying multiple cards, with next and previous buttons to navigate between them. The example includes 5 cards, each with a button. Clicking a button displays the next card. Clicking the next button navigates through the cards in the order they were added, while clicking the previous button navigates in the opposite direction. After reaching the last card, clicking next loops back to the first card. The card layout enables creating interfaces with multiple frame-like views accessible via buttons. The conclusion highlights that components like calculators with text field labels, buttons, and checkboxes can be included in applets. Layout managers help programs fix how components are managed, such as flow layout, border layout, grid layout, and others. Components like button and label are subclasses of Java.AWT component and can be added to applets or frames. The various layout managers discussed, such as border layout and card layout, were used to add components to applets and frames. The next module will discuss event handling, which has been referred to throughout the demo. In summary, the key takeaways are GUI components like buttons and layouts were demonstrated. Component creation and customization were illustrated. The potential for user input components was highlighted. An overview of various layout manager strategies was provided, and insights into building GUI-based applications were shared. Please stay tuned for more summary videos.